Welcome, everyone. We have entered a new era of cybersecurity where attacks occur at machine speed. Human speed defense is no longer viable. Today, we are exploring machine versus machine defense and how to build an autonomous security operations center in 2026. Let's get started. Let's begin with the what. We are experiencing a fundamental inflection point. The transition from human-driven attacks to autonomous, AI-driven exploits means attacks now execute in single-digit minutes. The basics are stark. Frontier AI models, such as Anthropic's Mythos, can autonomously identify and chain vulnerabilities, executing what used to take weeks of skilled manual effort in mere minutes. Why does this matter? Because standard human speed triage in a traditional security operations center is officially obsolete. How are attackers doing this? They deploy AI agents for everything from rapid reconnaissance to automated lateral movement. In our deep dive, we must recognize that the shift from AI-assisted to fully AI-driven attacks requires our defenses to adapt. Your mean time to detection and mean time to response must be measured in low single-digit minutes, or you will be outpaced. Looking at this timeline comparison, the top path shows the traditional attack lifecycle, where reconnaissance and exploitation take days, allowing human SOC triage to intervene. The bottom path illustrates the new reality. An AI-driven attack compresses reconnaissance and exploit chaining into seconds and minutes. The only valid countermeasure is the final node, an autonomous SOC response executing in microseconds. What exactly is an autonomous SOC? It is an AI-driven CM platform often referred to as the guardian AI layer that operates independently to detect and respond to threats. The basics involve moving away from siloed tools toward a consolidated data lake where AI normalizes and prioritizes signals in real time. Why is this mandatory? Because manual triage simply cannot scale to the volume of vulnerabilities and attacks generated by frontier AI models. How does it work? We deploy defensive AI models that triage alerts, summarize technical events, and constantly conduct proactive threat hunts. In our deep dive, we see that top-tier organizations are leveraging this guardian AI layer to isolate compromised API nodes in microseconds. It is machine fighting machine, responding faster than any human analyst could click a mouse. This flowchart maps the architecture of an autonomous SOC. Network telemetry streams into an AI-enabled data lake, providing the necessary context. This feeds the core autonomous SOC engine. The engine performs continuous loops of triaging alerts and launching proactive threat hunts. When an anomaly is detected, it triggers microsecond API isolation autonomously. Simultaneously, it summarizes the incident for a human security leader, ensuring humans supervise the strategy while the machine handles the tactical execution. Our third concept is proactive defense, specifically predictive patching. What is it? It's the deployment of defensive AI agents that scan your code 24/7 to predict and patch flaws before attackers strike. The basics rely on a radical, shift-left strategy where frontier AI is deeply integrated into your SDLC to break your own software during development. Why do we do this? Because the window between vulnerability discovery and exploitation has collapsed to nearly zero. How is this implemented? Organizations are deploying defensive Mythos instances to conduct continuous, autonomous red teaming. Diving deeper, predictive patching means that instead of waiting for a hack, these agents identify potential exploit chains and generate machine-coded patches autonomously. You are essentially using an elite AI hacker to permanently harden your perimeter from the inside out. Here we visualize the predictive patching pipeline. A developer commits code, initiating an immediate defensive AI scan. If a vulnerability is found, an autonomous red team simulates the exploit chain to verify the risk. It then instantly generates a machine patch and routes it for automated PR review. Once verified, or if no bug was found, the secure code deploys to production. This completely neutralizes zero-day gaps. Let's deep dive into how we catch these invisible attackers using behavioral KYT or Know Your Transaction. What is it? It's the use of AI to monitor the underlying intent of API calls, looking for the behavioral signature of an advanced AI agent rather than a human. The basics are that AI attackers use protocols like MCP to interact with systems, which leaves a distinct, superhuman footprint. Why do we need this? Because the 2026 standard dictates that static API keys are dead. An AI can steal a valid key, but its execution logic gives it away. How do we detect it? Security researchers use a joint loss function, L equals L, retrieve, plus L, action, plus lambda times L, stealth. This formula detects poisoned context injections designed to trick agents. In our deep dive, the autonomous SOC constantly calculates this loss function. If the timing and logic of API requests match an agentic signature, the system flags the interaction as a machine-driven attack and blocks it immediately. This architecture diagram breaks down the behavioral KYD engine. Every incoming API request is parsed into 3 analytical streams: the retrieval pattern, the action logic, and stealth indicators. The engine computes the joint loss function in real time. If the loss exceeds our defined threshold, it identifies the request as a malicious agentic signature and blocks it. If it stays below, it allows the traffic. This is intent-based security at the mathematical level. Slide 5 covers the new perimeter, the identity layer. What does this mean today? It means extending zero-trust frameworks to recognize AI agents as distinct, autonomous actors inside your enterprise. The basics are non-negotiable. Every single AI agent requires its own identity, tightly scoped permissions, and continuous governance. Why? Because more than 80% of breaches involve compromised identity. When an AI adversary discovers a vulnerability, identity verification is the ultimate kill switch that prevents exploitation. How is this achieved? Modern identity platforms now secure human, customer, and agent identities simultaneously. Deep diving into this, we must enforce a new standard of digital hygiene. Independent, neutral identity must sit across your entire stack. By executing rigorous device posture checks and continuous trust verification on AI agents, we stop autonomous lateral movement cold before data is ever exfiltrated. This state diagram demonstrates the modern authentication flow. An identity request hits the auth engine, which branches based on whether the entity is human or an AI agent. For agents, it applies the agent policy, demanding cryptographic hashes and enforcing tightly scoped permissions. Crucially, this enters a state of continuous trust verification. Access is granted as long as behavior remains expected, but the moment an anomaly is detected, the kill switch state is activated, terminating the session. What happens when an attack actually slips through? We must automate the incident response pipeline. This means deploying AI models to handle the heavy technical lifting during an active cyber attack. The basics are that manual TRIA is too slow. Models must automatically TRIA alerts and summarize events. Why? Because as AI accelerates vulnerability discovery, incident volume explodes. Human teams cannot simply staff their way out of this. How do we fix it? During an incident, the autonomous SOC acts as your lead investigator. It takes notes, captures forensic artifacts, and hunts for lateral movement simultaneously. In our deep dive, we see the AI instantly drafting the preliminary post-mortem and performing root cause analysis. This allows your human incident responders to step back from the technical weeds and focus entirely on high-level strategic validation and containment decisions. This sequence diagram maps out an automated incident response. The attacker executes an exploit against the system. Telemetry triggers the autonomous SOC. Operating at machine speed, the SOC reaches back into the system to capture forensic artifacts, while simultaneously running proactive threat hunts for persistence. It synthesizes this data and delivers a complete root cause analysis to the human responders, who then approve the final strategic containment measures. Let's apply this to a highly critical, real-time use case, defending an API gateway. Imagine a scenario where an external AI adversary targets a financial exchange. It attempts to chain a minor API vulnerability with an internal flaw to escalate permissions. The attack specifically exploits a sub-millisecond race condition in the order matching logic. Now, the defense activates. The autonomous SOC analyzes the incoming traffic and immediately detects the superhuman speed and sequential logic of the requests. The action is swift. The behavioral KYD engine flags the traffic as an agentic signature. In response, the Guardian AI layer isolates the compromised API node in microseconds. The result is a total victory for the defense. The attack is contained before the race condition is exploited, and the autonomous SOC immediately generates a predictive patch to close the flaw across the entire global network. Here we visualize the real-time API defense scenario. The adversary AI agent fires sub-millisecond requests at the financial exchange API. The autonomous SOC analysis intercepts the traffic, detects the attempted race condition exploit, and triggers the behavioral KYD flag. This leads to immediate isolation of the API node in microseconds. Finally, the system automatically generates a predictive patch and deploys a global hotfix, neutralizing the threat permanently. To conclude, how do we scale this defense across the globe? Enter the Beacon Network. What is it? It's a real-time intelligence sharing system that instantly broadcasts newly discovered adversarial signatures across the entire industry. The basics are simple. Immediate attribution ensures that an AI exploit used against one platform will instantly fail everywhere else. Why is this necessary? Because no single organization can survive the coming vulnerability tsunami alone. How it works is beautiful. Once your autonomous SOC detects a novel exploit stack, it pushes that signature through the beacon network to all participating venues simultaneously. In our final deep dive, we realize this architecture effectively creates global, digital herd immunity against malicious frontier AI models. AI is giving attackers their most powerful weapon, but it must and will become our ultimate defense. I invite all learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you. Our final mind map summarizes the machine versus machine defense framework. The core branches into 4 pillars. The autonomous SOC handles microsecond isolation and automated incident response. Predictive patching integrates shift-left strategies and continuous red teaming. Identity governance enforces agentic signatures and behavioral KYC. Finally, the beacon network connects everything, enabling real-time sharing to achieve ultimate digital herd immunity.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available like Microsoft. You can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.